بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are review exercises about chapter 3. Chapter 3 is about matrices and solving linear systems using matrices. So here perform the indicated matrix operations with the following matrices. So first we need to find A transpose plus B. Well, A transpose, if you remember, A is 3 by 2 matrix, 3 rows by 2 columns. So the A transpose would be 2 by 3. So we simply write the first row as the first column, the second row as the second column, and the third row as the third column. So this is A transpose. We need to add A transpose plus B, and we can add these two matrices because they have the same order. The order of each one of them is 2 by 3. So 1 plus 2 is 3, 3 minus 2 is 1, 4 plus 1 is 5, negative 2 plus 3 is 1, 2 plus 1 is 3, and 1 plus 5 is 6. So this is the matrix A transpose plus B. B minus C. Well, I have B. This is the matrix B minus the matrix C. The matrix C is also 2 by 3, so I'll be able to find their difference. Two matrices should be of the same order to find their addition and subtraction. So we simply find the difference between each two corresponding positions or elements. So 2 minus 3, negative 2 minus minus 4, 1 minus minus 1, 3 minus 2, 1 minus 2, 5 minus minus 1. So this will give you B minus C. Now C times D. This is the matrix C, and it is of order 2 by 3, and we need to multiply by the matrix D. 3, 5, 41, 3, 2, 3. Now, can we multiply these two matrices? The order of D is 3 by 3. If this equals to this, then we can multiply the two matrices, and the answer would be of order 2 by 3. And to find the product, we simply multiply the first row, this row, by this column, and put the answer here. So what to do? We multiply 3 times 1 plus negative 4 times 3 plus negative 1 times 3, and the answer would be negative 12. And then we multiply the first row in C by the second column in D. So 3 times 2 is 6, negative 4 times 5, and negative 1 times 2. So that's negative 16. And then we multiply the first row in C by the third column in D. So 3 times 4, is 12. Minus 4 times 41, and minus 1 times 3. So the answer is negative 155. And now I use the second row of C and multiply the second row of C by the first row of D. So 2 times 1 plus 2 times 3 minus 1 times 3. So this will give you 5. Second row times second column, 4 plus 10 minus 2, 12. Second row times third column, 2 times 4, 8, plus 2 times 41, minus 1 times 3. This is 87. So this is the product matrix CD. Now to find A times B times D, we can find AB first. A, B, D is equal to A, B, D. Whether you evaluated AB first and then multiplied by D, or BD first and then multiplied by A. So let me first find B times D. Okay. So this is the matrix B times the matrix D. Okay. So it would be A is 1, negative 2, 3, 2, 4, 1. So A would be multiplied by the product of these two, which is going to be 2 by 3 matrix. So like we did in part 3, 2 times 1 minus 2 times 3 plus 1 times 3. The answer is negative 1. 2 times 2 minus 2 times 5 plus 1 times 2, which is negative 4. 2 times 4 minus 2 times 41 plus 3. That's negative 71. Then the second row, 3 plus 3 plus 15, 21. 3 times 2 plus 5 plus 10. Again, 21. 3 times 4 plus 1 times 41 plus 5 times 3. This is 68. And now A is of order 3 by 2, and the product of BD is of order 2 by 3. We can multiply them because these two are equal, and the answer would be a 3 by 3 matrix. So we multiply the first row here by the first column, then the second, then the third, to give us the first row in the product matrix. So minus 1 minus 2 times 21. So this is negative 43. And then negative 4 minus 2 times 21, negative 46. And negative 71 minus 2 times 68, negative 207. Now the second row, negative 3 plus 2 times 21, 39. 3 times negative 4 plus 2 times 21, 30. 3 times negative 71 plus 2 times 68, negative 77. 4 times minus 1 plus 21, 17. 4 times negative 4 plus 21, 5. 4 times negative 71 plus 1 times 68, negative 216. So this is the answer. It would be a nice practice for you to check. Now I did it using this method. Multiply A times B first, and then the product you multiply by D from the left, like this. And you should get the same answer. Find the inverse of this matrix. Well, if this matrix is A, then A inverse, the formula says it is 1 over 1 times 4 minus 3 times 2. And 1 and 4, we change their positions. 2 and 3, we change their signs. So 4 minus 6 is negative 2. So 1 over negative 2 times 4, 4 over negative 2 is negative 2. Negative 3 over negative 2, negative 2 over negative 2, and 1 over negative 2. So this is the matrix A inverse. And you can multiply both matrices to check that A times A inverse and A inverse times A will give you the identity matrix. I2 in this case, 2 by 2. To find the inverse of this matrix, we know the procedure. We write the matrix. Let us call it the matrix A. And here I have 2, 2, 1, 4, 2, 4. I put a vertical bar and I write the identity matrix. And now I change the matrix to the left A to the identity, then the matrix to the right would be changed to A inverse. This number is 1 in the first row, first column, so I use it to make this number and the number below zeros. So negative R1 plus R2 and negative R1 plus R3. The first row is not changing. And these are zeros, so these numbers also are not changing. Now negative 1 plus 1 is 0, negative 2 plus 2 is 0, negative 4 plus 2 is negative 2, negative 1 plus 0 is negative 1. And negative 1 plus 1 is 0, negative 2 plus 1 is negative 1, and negative 4 plus 4 is 0, and negative 1 plus 0 is negative 1. I need the number in the middle to be 1 in the second row, second column. So I cannot make it 1, it's 0. So I interchange row 2 and row 3 because I have 1 or negative 1 actually below. So the third row will be transferred or moved to the second, and the second will be the third. This is the meaning of interchanging. And now I multiply row 2 by negative 1 because I need 1 here in the main diagonal. And the third row as it is. Now this 2 has to be 0. So negative 2 R2, I use R2, will make the 2 0. So I will have now the second row as it is. And the third row, there is no change. And this is 0, it will not change this number, and this is 0, so this will remain 4, and this is 0. Okay. Negative 2 plus 2 is 0. Negative 2 times 1 plus 1. So negative 2 plus 1 is negative 1. Negative 2 times negative 1 is 2 plus 0 is 2. So now this number negative 2 has to be 0. Has to be 1, sorry. So I could have divided here row 3 by negative 2 in the same step. There is no need to write it in a separate step. So negative 2 over negative 2 is 1. Negative 1 over negative 2 is half. And this is negative half. So now the last step would be to make this 4 0. So negative 4R3 plus R1. There is no change in the last row or in the second. Okay, but the first row would be changed. So I'm using the third row. So 0 0, these two will not change it, and this is 0, so this will remain 2. And now negative 4 plus 4 is 0. Negative 4 times half is negative 2 plus minus 1, that's negative 3. And negative 4 times negative half is 2 plus 0, that's 2. So A inverse would be the matrix negative 3, 2, 2, 1, 0, negative 1, half, negative half, and 0. And you can check your answer by multiplying A times A inverse or by using the calculator. Find the matrix X if AX equals B. We know that if AX equals B, then X equals A inverse times B. And A inverse is given. So X would be X, Y, Z, the matrix of unknowns. And it would be equal to A inverse times B. 3 by 3 times 3 by 1, you get 3 by 1. So 3 plus 2, that's 5. 9 plus 1 plus 4, that's 14. 12 plus 1 plus 2, that's 15. So that's the answer. X is 5, Y is 14, and Z is 15. That's the solution. The reduced matrix for system of equation is given. All right, identify the type of solution for the system. Unique, no solution, or infinitely many solution. Explain your reasoning. Well, here I have infinitely many solutions. And the reason because I have 0 equals to 0. And this is always true. So I have x minus 2z equals 6 and y plus 3z equals 7 and 0 equals to 0, which is always a true statement. So I have here two equations in 3 variables. So I must have infinitely many solutions. For each system that has a solution, find it. So the solution would be x equals 2z plus 6, y equals negative 3z plus 7. This is a plus. And z could be any real number. And if you want, you can replace z by 0 and find a solution. By 1, you find another solution, and so on. So because we have 2 equations and 3 variables, there will be infinitely many solutions. While here we have 0 equals to 1 from the last row, and this is not possible. So this system has no solution. Okay, whatever I replace x, y, and z by, I can never make 0 equals to 1. So this system has no solution. Inconsistent system. Given the following augmented matrix representing a system of linear equations, find the solution. So the augmented matrix is given and we need to find the solution. Okay, if this is the augmented matrix, then I have to change this matrix, the coefficient matrix, to the identity matrix. So we work as usual, column by column. This number is 1. I make it to use the 4 and 2 zeros. So negative 4 times R1, I use R1 plus R2, and negative 2 times R1 plus R3. So the new matrix would be R1 is not changing, 1, 1, 2, and 5. Now negative 4 plus 4 is 0. Negative 4 plus 0 is negative 4. Negative 8 plus 1 is negative 7. Negative 20 plus 5 is negative 15. Third row, negative 2 plus 2 is 0. Negative 2 plus 1 is negative 1. Negative 4 plus 1 is negative 3. Negative 10 plus 5 is negative 5. Now I need to make the negative 4 1, but I have negative 1 below. So I will interchange row 2 and row 3. If you want to divide here by negative 4, that's correct. There is no problem with it. But the calculations will contain fractions. And dealing with fractions is usually more difficult. So I will multiply row 2 by 1. So I get 1, 1, 2, 5, 0, 1, 3, 5, 0, negative 4, negative 7, negative 15. Now the number in the second row, second column is 1. I use it to make the one above 0. And the negative 4, I need it also to be 0. So I finish from this second column by this way. In my way to make this matrix the identity matrix. So here the second row is not changing. And I have 0 here. So this is 1 and this is 0. And now negative 1 plus 1 is 0. Negative 3 plus 2 is negative 1. Negative 5 plus 5 is 0. And 4 minus 4, 0. 8 minus 7, 1. 20 minus 15 is 5. This number is 1. I am lucky, so I will use, let me check something. Is there any mistake? Negative, I'll go from here. Negative 4 plus 4, 0. Negative 4, negative 7, negative 15, negative 10. Okay, negative 4, good. This is correct. And here, negative 1, negative 3, negative 5, negative 4, negative 7, negative 15, good. So this is 1, 3, 5, negative 4, negative 7, negative 15. That's also good. And here, 4, 12 minus 7. Yeah. Oh, 4 times 3, 12. Minus 7, that's 5, not 1. So this is 5. Good. And 4 minus 4 is 0. So you usually need to check your answers because it's easy to make a mistake here. So R 3 over 5. So we get the matrix 1, 0, negative 1, 0, 0, 1, 3, 5, and 0, 0, 1, 1. And now we use this one to make these two numbers zeros. So negative 3 R3 plus R2 and R3 plus R1. And here the last row is not changing. And since these two are zeros and we're using the last row, so these numbers will not going to be changed. And now negative 3 plus 3 is 0, and negative 3 plus 5 is 2, and 1 minus 1 is 0, and 1 plus 0 is 1. And this means that x is 1, and y is 2, and z is 1. And that's the solution of the system. Solve each system using matrices. When he say using matrices, he means Gauss and Jordan. So Gauss and Jordan, we first write the augmented matrix. 1, negative 3, negative 2, 10, 4, 24. This is the augmented matrix. And then we change this matrix to the left to the identity matrix. So this is 1. I multiply row 1 by 3 and add it to row 3. So I will get 1 minus 2, 4, no change in first row. 3 minus 3 is 0. Negative 6 plus 10 is 4. 12 plus 24, that's 36. So 12 plus 24 is, 36. Now I divide by 4 to make this number 1. So 1 minus 2, 4 without any change. 1 and 36 divided by 4 is 9. Now 2R2 plus R1. This would be the last step. So I have, and 2 minus 2 is 0. 2 times 9 is 18 plus 4. That's 22. So x is 22 and y is 9. And that's the answer. And you can check it immediately. 9, 22 minus 18 is 4. And it's easy to check in the two equations. Same question. So let us write the augmented matrix. 1, 3, negative 2, 1, 2, negative 3, all right, and negative 2, 5, and 15, and this is 5, 10, and 2. This is the augmented matrix. This number has to be 1. It is already 1. Let me check that I did not do a mistake. Okay, good. So negative 3R1 plus R2 and 2R1 plus R3 will make the first column 1, 0, 0. So 1, 1, negative 2, 5, no change. Negative 3 plus 3 is 0. Negative 3 plus 2 is negative 1. 6 plus 5 is 11. Negative 15 plus 10 is negative 5. 2 minus 2 is 0. 2 minus 3 is negative 1. Negative 4 plus 15 is 11. 10 plus 2 is 12. You can see negative 1, 11, negative 1, 11, and these two are different. So this means that there will be no answer, okay? So negative, anyway, I'll continue to write it in the reduced form. So 1, 1, negative 2, and 5, 0, 1, negative 11, and 5, and here 0, negative 1, 11, and 12. Now I use this one to make the one above 0 and the negative one below also 0. So there is no change in the second row. And now also this is 0. It will not change these two numbers. Okay. Negative 1 plus 1 is 0. 11 minus 2 is 9. Negative 5 plus 5 is 0. And 1 minus 1 is 0. Negative 11 plus 11 is 0. 5 plus 12 is 17. And you can see here that 0 would be equal to 17. There is no answer. I cannot continue because this 0, I cannot make it 1. So I stop here. 0 equals 217. This is not possible. So there is no solution. Okay. This system has no solution. Solution set is phi, and the system is inconsistent. Let us do this one. Write the augmented matrix. Z, the coefficient of Z is 0 in the first equation, and 3, 1, 7. Let me check. 1, negative 1, 0, 3, 1, 1, 4, 1. All right. This is 1, so negative R1 plus R2, and negative 2R1 plus R3. Okay. So the first row, no change, 1 minus 1, 0, 3. And now negative 1 plus 1 is 0. 1 plus 1 is 2. And 0 will not change anything. And negative 3 plus 1 is negative 2. Negative 2 plus 2 is 0. 2 minus 3 is negative 1. And negative 6 plus 7 is 1. You notice that I can divide here by 2 to make it 1, because I need to make it 1. 1, 2, negative 1. And you notice now that I have here the negative numbers of the second row. So this means infinitely many solutions. R2 plus R1 and R2 plus R3 to make the second column 0, 1, 0. So here the second row, no change. And the first row is 1 minus 1 is 0, 2 plus 0 is 2, negative 1 plus 3 is 2, 1 minus 1 is 0, 2 minus 2 is 0, negative 1 plus 1 is 0. And now this number is 0 and I cannot change it to 1, so I stop here. I write the equations. I have 0 equals to 0, so this means infinitely many solutions. X plus 2z is 2, that's the first equation. And y plus 2z is negative 1, this is the second equation. And the last equation is 0 equals to 0. So the solution would be x equals negative 2z plus 2, y equals negative 2z minus 1, okay? And z could be any real number. Did he ask to give? No, he did not say anything. If he needs, we can choose z, for example, 0, and give him one of the solutions. So one solution would be x2, y negative 1, and z 0. Another solution you can find if z is 1. A third solution if z is negative 1, and so on. Find the determinants. Remember, this is a matrix. We write like this. This is determinant. So the determinant, this determinant is equal to 4 times 2, that's 8, minus negative 4, negative 2 times 8, that's negative 8. Well, 8 plus 8 is 16. So the determinant is 16. This is part A. And part B, use it to decide whether the matrix has inverse. Yeah, if this is the matrix A, then A has inverse because the determinant is not 0. Solve each system using inverse matrices. Now, using inverse matrices, we write a matrix equation. We say, I write the coefficient matrix 1, 3, 1. The coefficient of y is 0, 4, 1, 2, negative 1, 0. This is the matrix A, or the coefficient matrix, times x, y, z, the unknown, which is x, equals the matrix B, which is the matrix of constants. And now to solve this system, we need to find A inverse. And to find A inverse, I do the usual procedure. So I write the identity matrix here, and I change this matrix to the identity matrix. Well, I have 1, so I use it to make -3. This is -3 R1 plus R2. To make the -3 0, and negative R1 plus R2 also should be 0. So the first row is not changing. And we have zeros here, so I'll still have 1 0 and 0 1 here. And this is 0, so this will remain 0 4. -3 plus 3 is 0. -6 plus -1 is -7. -3 plus 0 is -3. -1 plus 1 is 0. -2 plus 0 is -2. And -1 plus 0 is -1. Now the 4 has to be 0, but I have 1 below. So I'll immediately interchange row 2 and row 3. So row 1 as it is, and row 2 will be here, row 3 will be here, and row 2 would be here. -3, 1, and 0. Excellent. Now I use this one to make this 4 0, so -4R2 plus R3. Row 1 as it is. Row 2 also without any change. And now row 3. -4 plus 4 is 0. 8 minus 7 is 1. 4 minus 3 is 1. This is 1. And this is -4. Excellent. So this is 1. I use it to make the -2 0. And also the 2 0. So here the last row is not changing. And I have here 0, 1, and 2 minus 2 is 0. 2 minus 1 is 1. 2 plus 0 is 2. -8 plus 1 is -7. And -2 plus 2 is 0. And -2 plus 1 is -1. And -2 here. And 8 plus 0 is 8. So now I have A inverse, and I can find the system. I can solve it. So x, y, z equals A inverse, which is -1, -2, 8, 1, 2 minus 7, 1, 1 minus 4, should be multiplied by 5 to -3. Is it? Yeah. So the answer would be -5, -5 minus 4 minus 24, which is -33. And 5 plus 4 plus 21, that's 30. And 5 plus 2 plus 12, that's 19. So x is -33, y is 30, and z is 19. And this is the end of this exercises.